let me know if you can see my screen.
Yep.
Yes, that's fine.
Yep.
Okay, perfect. Very good. So I'll make this a bit bigger. Okay, so I work in consulting, but actually what we tend to do is we build software. Basically, we build applications for businesses, right? That's basically what we do, right? We use a particular platform, but that level of detail is probably not required at this stage. But I just wanted to get you a sense of how things have changed since the inception of programming. So programming and basically programming is building anything on a computer. Right? It started in the 1940s, right? So that right? So I was born in 75, right? And the first computer I got was in 1982, and it was a 48 kilobyte computer. Just to give you a sense of a 48 kilobyte computer, that's probably just a couple of email messages in terms of the memory it could store, right? And that was, I said, about 4 decades ago. Now, as we know, just any basic computer these days can storage and work with, gigabytes of data, right? So I just wanted to give you a sense of how things have evolved and how quickly they're evolving, because I think that's probably that rate of acceleration is also quite important to this topic, particularly. I said, computers, became programmable in the 40s, right? Just around the Second World War, but actually they became something that you could buy in a shop, right? In the, I'd say 70s, 80s, right? Dave, Les, you might have a different view, but I think 70s, 80s is about right. Right?
Yeah.
Right. So it took about 3 decades, maybe 4, from having something that you could program to actually people being able to buy one. Now, in around 2012, they mentioned here, but somewhere in the 2010s, deep neural networks actually became popular, and they meant a change in the way you program computers. Because before, I'll show you some examples. You actually tell the computer, hey, please, well, not please, because actually it was much more direct, but actually you will ask the computer to, print something on the screen, to actually look at certain variables. We'll see some examples. But now, basically what happens is computers are based on weight. And that means basically, on probabilities. Let's put it that way, right? So certain things are more likely to happen based on an input and an output. But now, in just less than a decade, right, we have the next jump in programming, which are large language models, which is what you have been using recently. And these are actually, as you know well, these are actually managed using prompts. Just to give you a sense, right? So ChatGPT has been around with us for just over a year. I think it was November 2023 when it became available. And the rate of usage has been the highest ever seen on any application or any technology, right? So from the moment they got 1 user to the moment they got 1 billion people using it, I think it was a matter of a few months. Just to give you also that sense of, things are speeding up, and, there's a lot of things that will change. And probably in your lifetimes, you will see many of these changes as well. Meanwhile, maybe Les, Dave, and myself, so far we've only seen 3. Probably in the next 10, 20 years, there's going to be, at least a similar amount of changes. Now, I will stop there. Does that make sense? The 3 types of ways in which computers have been programmed? You're aware of that? Yeah.
I think it would be helpful if you just just very quickly maybe ran through software 3, so we actually understand that output there,
Sure.
what you're showing there. That would help me anyway.
Of course. Let's actually put a simple example of how things have been done in these 3 phases, in these 3 waves. And just so that you know, all these 3 waves are still active. So my team and myself, I still do software 1.0 work, right? So basically that means, I tell the computer, right, how to analyze, for instance, this is an example of analyzing sentiment in a message, right? And there are people that still use this approach, which is, okay, if you find in the text words like good, great, love, excellent, then rate the sentiment of the sentence as positive, right? And if you find words like awful, poor, etc., just categorize the sentiment as negative, right? And that's basically what this code routine does. Now, in software 2.0, the way in which this changes is there's no one actually programming and telling the computer what to do. What we are doing is we're giving the computer a lot of examples, right? You can see, for instance, 10,000 positive examples and 10,000 negative examples. That's why having a lot of data, it's quite important. And this, this shift into software 2.0 only happened once we have the internet and we have plenty of data, right? So, and basically the way you program in software 2.0 is you just give a lot of examples, right, to a neural network. And then the neural network, what it does is it encodes that information, right? So that, it actually understands what a positive sentiment or, a positive category of sentiment is and what a negative, category would be. Now, in software 3.0, you just tell your LLM, okay, you're a sentiment classifier. For every review that appears between the tags, respond with exactly one word, either positive or negative. And that's how you actually instruct your application to determine whether something is positive or negative. You can see that, there's a big shift, right, in terms of software 1.0. You basically programmatically specify all possible words. Software 2.0, which is based on a lot of data, right? And software 3.0, where you actually tell them what to do. And because software 3.0 relies on software 2.0 and understands what positive language and negative language is, it actually can respond based on your prompt. Okay, I will stop here because I guess it's
that's great. That's very helpful. Thank you.
No worries. That doesn't make sense. Yeah.